Imagine you're in your kitchen, cooking dinner, when suddenly you slip. The knife in your hand nicks your finger, and instantly, blood starts seeping out. Panic sets in. You grab a tissue, but it's not enough. Then, instead of reaching for a bandage, you do something that seems almost bizarre. You pull out a small tube of superglue, squeeze a drop onto the cut, and watch as the bleeding stops almost instantly. Within seconds, the wound is sealed shut.
Curious about how the world really works? Not the myths, not the shortcuts, the real science behind everything we see and experience. On this channel, we explore mind-bending physics, unravel the secrets of the universe, and uncover the hidden patterns that shape our reality. If that excites you, subscribe for weekly deep dives into science and discovery. Hit like and share with friends. Your curiosity drives our next adventure. Leave a comment and let us know what puzzles we should solve together.
It sounds almost like something from a survival hack video, right? But here's the twist. It's not just a hack. Superglue, the same stuff sitting in your drawer for fixing broken mugs or repairing a shoe sole, has an incredible hidden use. It can actually close up wounds. And in fact, it's so effective at sealing skin that the military, surgeons, and even emergency doctors have relied on glue-like compounds for decades when speed and precision were critical. But here's the question. Why is superglue perfect for gluing skin? That's what we're going to explore today. We'll uncover the surprising history of this sticky invention, the science that makes it work, and why it bonds to skin in ways that almost seem magical. We'll also look at how it transformed from a household adhesive into a medical lifesaver, and why it's both a blessing and sometimes a risk when it comes to human skin. So buckle up, because by the end of this video, you'll never look at that tiny tube of glue the same way again. The accidental invention and history of superglue. The story of superglue begins not in a hospital or a science lab dedicated to medicine, but in the middle of a wartime race for technology. The year was 1942. World War II was raging, and chemists were hard at work searching for materials that could give their side the edge. Among them was a man named Dr. Harry Coover, a researcher at Eastman Kodak. His mission wasn't to create an adhesive at all. Instead, he was tasked with developing clear plastics that could be used for precision gun sights. During his experiments, Coover and his team came across a chemical compound known as cyanoacrylate. At first glance, it seemed promising, but very quickly they realized this compound was more trouble than it was worth. Why? Because it stuck to everything. Every test, every attempt to shape it into a useful plastic failed. Imagine trying to mold a material only for it to glue itself to your instruments, your workspace, and even your hands. For Coover, cyanoacrylate wasn't just inconvenient, it was a nightmare. So the project moved on and the compound was shelved. Fast forward to the 1950s. By now, Coover had moved on to another research project, still with Kodak. This time, he and his colleagues were working on heat-resistant materials for jet canopies. During the testing phase, one of his assistants spread out a thin layer of cyanoacrylate between two prisms to check how much light would pass through. But when they tried to separate the prisms, they couldn't. The two pieces of glass were permanently fused together. And suddenly, the team realized they weren't dealing with a failure at all. They had discovered one of the strongest adhesives in history. By 1958, this miracle glue was introduced to the world as Eastman 910, the first commercially available superglue. It was marketed as an all-purpose adhesive that could bond almost instantly to metal, glass, wood, and yes, to skin. Now, here's where things get fascinating. Almost immediately, people noticed its unusual ability to stick so firmly to human tissue. Unlike traditional glues, which either peeled off or lost strength, cyanoacrylate formed a tight, waterproof, nearly seamless bond. That accidental stickiness became the key to something far greater than fixing broken household items. It opened the door to medical innovation. But the leap from household product to surgical tool didn't happen overnight. It took the urgency of war, battlefield injuries, and desperate medics improvising in life-or-death situations to show just how powerful this sticky invention could be for skin.
The science of why superglue sticks to skin. To understand why superglue is so perfect for gluing skin, we need to zoom in, way in, down to the molecular level. Unlike most traditional adhesives, superglue doesn't rely on heat, pressure, or long drying times. Instead, it works through an incredibly fast chemical reaction called anionic polymerization. Here's how it works. The main ingredient in superglue, cyanoacrylate, comes in the form of liquid monomers, tiny single molecules floating freely. On their own, they're stable and don't do much, but the moment they come into contact with even the tiniest trace of moisture, something extraordinary happens. And here's the key. Our skin is covered in moisture. Even if it feels dry to the touch, there's always a thin layer of water molecules sitting on the surface, along with natural oils and proteins. When superglue touches this moisture, the cyanoacrylate molecules snap together in an instant, forming long chains called polymers. This reaction is not just fast, it's almost explosive. Within seconds, those free-floating molecules harden into a strong, plastic-like solid. That's why when you use superglue on your fingers, it feels like the glue froze instantly, locking your skin together. But why does it stick so well specifically to skin compared to, say, metal or glass? The answer lies in the texture and chemistry of human tissue. Our skin isn't smooth. It's full of ridges, pores, and microscopic irregularities. When superglue flows over it in liquid form, it seeps into those tiny crevices before hardening. Once the polymer chains lock into place, they form a physical bond that's almost impossible to break without tearing the skin itself. On top of that, skin contains proteins like keratin, which provide even more reactive sites for the cyanoacrylate to latch onto. This creates not just a surface-level hold, but a chemical grip. In other words, superglue doesn't just sit on skin, it merges with it on a microscopic level. This unique chemistry explains why a single drop of superglue can seal a cut so effectively. The polymerized layer acts almost like an artificial scab, flexible, waterproof, and strong enough to keep the wound closed while the body heals underneath. But of course, with every powerful invention comes a warning. Because superglue binds so aggressively to skin, it can sometimes work too well. We'll get into the risks and dangers later, but first, let's see how this science made its way from accidental kitchen injuries all the way to the battlefield, where superglue literally saved lives. Superglue in war and medicine. The leap from a sticky household product to a medical safe-liver didn't happen in a lab. It happened on the battlefield. The Vietnam War, in particular, became the proving ground for superglue's potential in saving lives. Soldiers in combat zones faced devastating injuries, gunshot wounds, shrapnel cuts, and deep lacerations. In those moments, time was everything. A wound left open for too long could lead to severe blood loss or infection before the soldier ever reached a field hospital. Traditional methods like bandages and tourniquets helped, but they weren't always enough. That's when military medics began experimenting with cyanoacrylate sprays. Instead of trying to stitch a wound under chaotic battlefield conditions, they could spray a layer of medical-grade glue directly onto the injury. The effect was almost miraculous. Bleeding slowed, tissue sealed, and soldiers who might have died from blood loss were stabilized long enough to be evacuated. Some accounts suggest that tens of thousands of soldiers survived injuries because of this improvised use of glue. And although it wasn't officially approved medical device at the time, the results were undeniable. The glue didn't heal the wound in itself, but it bought precious time. It created a temporary barrier that acted like an instant suture, something no other tool could do as quickly or effectively. Word of its success spread, and researchers began to take notice. Soon, specialized versions of cyanoacrylate were being developed specifically for medicine. These medical glues were formulated to be less toxic and more flexible than hardware store superglue, making them safer to use directly on skin and tissue. By the late 19th century, products like Dermabond and other surgical adhesives became mainstream in hospitals. Doctors started using them in place of stitches for small cuts, surgical incisions, and cosmetic procedures. They were especially valuable for closing wounds in children, where traditional sutures might cause trauma or scarring. Think about how revolutionary this was. Instead of threading a needle through delicate tissue, doctors could simply apply a few drops of adhesive, hold the wound edges together for a few seconds, and the patient walked away with a sealed, nearly invisible closure. It wasn't just faster, it reduced pain, minimized scarring, and lowered the risk of infection because the glue created a waterproof barrier. In some surgeries, it even eliminated the need for removing stitches later, since the glue naturally sloughed off as the skin healed. So from soldiers on battlefields to patients in operating rooms, superglue went from being an accidental invention to a medical revolution. But here's the fascinating part. It all circles back to the same question: why is this substance so perfect for gluing skin? We've looked at the history and the chemistry, but now it's time to dig into the practical benefits, the real reasons why even today, glue often beats stitches in certain situations.
Why superglue works so well for wounds compared to stitches. When you think of closing a wound, the first image that comes to mind is usually stitches. A doctor carefully threading a needle through the skin, pulling the wound shut, and tying neat knots. For centuries, this was the gold standard. But once superglue entered the picture, doctors realized it had some surprising advantages. First and foremost, speed. Stitches take time. A surgeon or medic needs to carefully align the wound edges, pierce the skin multiple times, and tie each stitch securely. On the battlefield or in an emergency room, every second counts. With medical-grade superglue, the process is almost instant. A few drops applied along the wound, some gentle pressure to hold the edges together, and within seconds, the cut is sealed. In situations where patients are losing blood rapidly, that time saved can be the difference between life and death. Second, pain and trauma. Stitches hurt. Even with anesthetic, the process of sewing through skin can be uncomfortable and, for children, terrifying. Glue, on the other hand, is non-invasive. There's no needle puncturing the skin repeatedly. For kids with playground injuries or patients undergoing small surgeries, glue feels less traumatic and far more tolerable. Third, scarring. When stitches are pulled through skin, they create tiny puncture marks along the wound. Over time, those marks can lead to more noticeable scars. Glue, by contrast, bonds the wound edges without extra holes, often leading to smoother healing and less visible scarring. This makes it especially valuable in cosmetic or facial surgeries, where appearance matters. Fourth, infection control. Stitches leave small gaps where bacteria can sneak in, and unless they're carefully sterilized, the thread itself can sometimes harbor microbes. Superglue forms a continuous, waterproof barrier. Once it's in place, it locks out dirt, bacteria, and moisture, reducing the risk of infection. It's like having a built-in shield over the wound. Fifth, no removal required. Anyone who's had stitches knows the hassle of going back to the doctor to get them taken out. Glue eliminates that step. As the skin naturally regenerates, the adhesive simply flakes off on its own, leaving behind healed tissue without the need for extra procedures. Of course, it's not all perfect. Glue isn't suitable for every kind of wound. Deep cuts, jagged injuries, or areas under constant movement often still require traditional sutures or staples. Glue also carries some risks of irritation if applied incorrectly. But in many everyday scenarios, from surgical incisions to small household accidents, it's not just a convenient alternative, it's the superior choice. So when we ask why superglue is perfect for gluing skin, it's not just about the science of bonding. It's about the very real practical advantages it gives us in healing. Faster closure, less pain, fewer scars, and lower infection risk. And yet, with all of these benefits, there's one question we need to address. Because every time someone hears, "You can use superglue on skin," they wonder, is it actually safe to use the same glue from the hardware store? Or is that crossing a dangerous line?
The risks, dangers, and safe uses of superglue on skin. While superglue has earned its reputation as a fast and effective wound sealer, it's not without potential hazards. Using the wrong type of glue or applying it incorrectly can turn a helpful solution into a painful problem. Understanding the risks is crucial if you ever consider using it on skin. First, let's talk about chemical irritation. Household superglue isn't formulated for medical use. It contains additives and stabilizers that can irritate the skin. In some cases, people develop redness, itching, or even a mild chemical burn if the glue is applied directly to sensitive tissue. That's why medical-grade adhesives like Dermabond or Liquiband are preferred. They're formulated to minimize irritation and are approved for skin contact. Next, there's the risk of bonding the wrong things together. Superglue is notorious for sticking to everything. Fingers, lips, eyelashes, or even eyes can accidentally come into contact with the adhesive, causing painful and sometimes dangerous sticking. For example, glue accidentally bonding eyelids together is rare, but it has happened in mishaps involving children or distracted adults. Another concern is trapped bacteria or debris. If the wound isn't properly cleaned before applying glue, you could seal in dirt or pathogens, which increases the risk of infection. A glued-over wound that becomes infected can worsen quickly because the glue forms a waterproof barrier that traps bacteria inside. Flexibility and movement are also important considerations. Superglue forms a hard, rigid bond. On areas of the body that bend or stretch frequently, like fingers, knuckles, or joints, the glue can crack or peel off prematurely. In contrast, medical adhesives are engineered to flex with the skin, maintaining the seal even during movement. Now let's address safe use guidelines. If you ever find yourself in a pinch and must use adhesive on a minor cut, follow these steps. Clean the wound thoroughly. Wash with water and mild soap, remove any debris, and gently dry the surrounding skin. Apply a tiny amount. 1 drop per ½ inch of wound is usually enough. Excess glue can ooze into unwanted areas. Hold the edges together. Press the skin gently for 10 to 30 seconds until the glue sets. Avoid sensitive areas. Don't use glue on eyes, mouth, or deep puncture wounds. Monitor healing. If redness, swelling, or pus develops, seek medical attention immediately. When used correctly, superglue can be a safe, effective, and even life-saving tool for minor injuries. But misuse, like applying industrial-grade glue from a hardware store without care, can lead to burns, allergic reactions, or permanent skin damage. So while the chemistry and practical advantages make superglue ideal for bonding skin, the margin for error is narrow. Knowledge and caution are key. Understanding these risks doesn't diminish its power. Instead, it highlights why medical professionals spend decades perfecting adhesives for safe human use. And now, knowing the history, chemistry, benefits, and risks, you might start to see why this little tube of glue is far more than just a household staple. It's a tool that has changed the way we treat wounds forever. From accidental discovery in a war lab to life-saving tool on battlefields, superglue has proven time and again that its power goes far beyond fixing broken mugs or shoes. Its unique chemistry, speed, and strength make it perfect for gluing skin, offering faster healing, less pain, and reduced scarring compared to traditional methods. But remember, while it's incredible, it's not magic. Proper cleaning, careful application, and using medical-grade adhesives whenever possible are essential for safety. So, next time you see that tiny tube of glue sitting on your shelf, think of it not just as an adhesive, but as a little miracle of science, ready to protect, seal, and save lives when used wisely.